Hello and welcome to Science Never Stops. I'm your host, Joseph Vick with the U.S. Space and Rocket Center, here today with NASA Marshall Space Flight Center guest, supermassive black hole and galaxy expert, Dr. Chien-Ting Chen. Welcome, Dr. Chen, to Science Never Stops.
Hello, Joseph. Nice meeting you. It's a pleasure being here.
Yes, glad you are here. So for our first question, could you please explain to our viewers your field of study and tell us about some current NASA projects you're working on?
Right. So I mainly study supermassive black holes in the center of galaxies. And by supermassive, I mean they are millions to billions times the mass of the sun. And these are pretty massive objects, but compared to the size of the galaxies, it's actually pretty small. It's kind of comparing a grape to the size of the Earth. But somehow their evolution is linked, and I'm very curious as to why that would happen. And to study this, I use various NASA missions to observe these, I guess, monsters in the universe. And the missions that I use, particularly in Marshall, is the Chandra mission, led by Dr. Weisskopf in our X-ray group. And also, the other mission that I'm heavily involved on is a Russian-German mission called SRG, and there are two telescopes on that mission, and Marshall is involved in one of the telescopes called ART-XC. We usually just call it ART, so I'm involved in Chandra and ART.
Well, do you happen to have a favorite black hole that you study or have seen?
Yeah, so my favorite galaxy and black hole system is an object called Markarian 231. It's a pretty luminous galaxy with a very interesting, very powerful black hole that's doing crazy stuff. And its galaxy is also interesting, and the whole system is just very interesting.
So could you tell us a little bit about your educational background and how that helped you obtain your current NASA position?
Right, so I'm from Taiwan originally. I did an undergrad in Tsinghua University in Taiwan, and I moved to the US, got a PhD in physics at Dartmouth College. So I guess that helped me in, gaining knowledge on physics, and also learn how to communicate efficiently with other scientists. But I think you don't really need tons of education to start doing science. There are lots of citizen science projects, for example, that you can start getting involved with. But to do the next step, to do like data analysis and interpretation and then communicate with other scientists, that's where you need the next level education so that you can make this as a career. But if you are interested in science in general, you don't need a ton of education to do that.
Was your PhD and dissertation that you wrote in black hole, supergiant, massive black hole science or astrophysics?
Yes, the connection between supermassive black holes and their host galaxies.
So it's the galaxy that hosts the black hole, not the black hole that hosts the galaxy.
Yeah, so like I said earlier, we call them supermassive black holes because they are much more massive than your typical stellar mass black hole, which are the end product of like supernova. But in the past 2 or 3 decades, astronomers have found that in almost every massive galaxies, there's a very, very massive black hole in their center, just one, in most of the cases. And somehow, even the size of the black holes in the galaxies are very different. Their evolution, in terms of their properties, for example, mass, are still tightly connected. It's kind of interesting to personally, I think it's the most interesting question out there for astrophysics, because why, let's say, why would, say, your head circumference, for example, the average head circumference of a nation is proportional to, say, the population of that nation. It's kind of having that connection is weird. But if you think a little bit about the physics in black holes, you can kind of see that's actually pretty cool, because making a black hole would give you a lots of energy, basically. Enormous amount of energy will be released.
So the supermassive black hole, the mass of the black hole, does it determine the shape of a galaxy per se? Could a supermassive black hole determine a spiral, elliptic galaxy? Is that determined or a factor at all?
Well, you know what? That's a very good question. So the relation between the black holes and galaxies are usually quite complicated. Sometimes when material falls onto a black hole, that can make those material while falling in will be thrown out by the strong magnetic field and gravitational field of the black hole, making jets that actually can push gas outside of the galaxy to several galaxies away. And that itself is an important process in the evolution of galaxies. So in a way, I would say, yes, there's definitely a role for black hole in shaping the galaxies, but how exactly different shapes of galaxies were affected by the black holes, or vice versa, how massive the black holes were affected by the shape of galaxies is pretty interesting, and I think it's still an open question.
Okay, so it sounds, from you speaking on different parts, it sounds like it's almost like a symbiotic relationship.
Yeah, exactly.
Together for a big system. The black holes are a fascinating topic. Everybody loves to talk about and read about. But growing up, was there a certain class or extracurricular activity, mentor, or experience that helped shape your career path or your interest in supermassive black holes or science in general?
Yeah, so I took several, I majored in physics, but I took several courses in astronomy and did a project studying, solving the general relativity equations to find how to grow a black hole, basically. So that course that I took, the professor from which I took the course, his name was Mike Tai, and also the other introductory astronomy course that I took with another astronomer in Taiwan. He's now retired in the US. His name is Frank Shu. So from these two, I would say these two are play an important role for me to decide to pursue in studying black holes in astrophysics. So
with your academic career, what would you say would be your biggest academic or career setback, and how did that setback, how did you overcome it? How did you reach a greater goal or better part? Because with science, some things don't always go the way you want them to.
Right. So I guess at the early stage of my graduate school, I would say I spent a lot of time trying to figure out a question by myself that turned out to be a dead end, and took me almost a year to figure it out. And then I figured out if I had just asked somebody who was senior than me or more wise than me, I would probably have solved that question in just a few days. So I guess that's when I learned how important communication is, especially don't be afraid to ask questions you have, even though they might seem naive or dumb. But there are no dumb questions. And I learned that I need to ask my questions and communicate efficiently with other people. And that is actually something that I now enjoy very much.
That is great advice. So at any level, even advanced astrophysicists even ask questions, and even the youngest starting out child asks questions. So it's all about asking questions and determining what are the right questions. So even wrong questions can lead to right answers sometimes. So who would you say is your favorite scientist and why?
Yeah, that's an interesting question. I would say Einstein. I mean, there are many others, but I still think Einstein would be my favorite.
Because you mentioned earlier you did some studies with relativity.
Yeah, and I think the theory on gravity is especially interesting. He has special theory of relativity and also general theory of relativity. Both are great achievements, and I think if you study his theory in detail, it's just pretty impressive. Yeah,
and it's amazing the super science that he worked with in those relativity equations, and using the pictures in his mind to piece these mathematical things together still are relevant in solving questions asked today.
Yeah, I once heard someone, I think when I was taking the course in relativity, I believe my instructor said general theory of relativity mathematically is too beautiful to be wrong. I mean,
what a great way of looking at that. Mm-hmm.
I wouldn't say it's perfectly correct, but it's certainly one of the most beautiful equations out there, and it can explain a lot of interesting and exciting things in the universe. And I would say that's why I would pick Einstein as my favorite scientist. It's kind of cliche, but you have to.
No, he's a good one to choose. Now, do you happen to have any special abilities, talents, or hobbies that might surprise people?
Well, I was trying to come up with one, that sounds cool and you cannot verify. But turns out I don't have that kind of skills. I would say I can solve a Rubik's Cube pretty fast.
Really?
But not like in seconds, maybe 1 or 2 minutes.
So would you happen to have a personal motto or set of advice to pass along to the next NASA career generation? From your past experience, what you've done, what you're doing currently, but that next generation, what would your piece of advice be for them?
Right. I guess I don't really have a 1 or 2 sentence personal motto, but as for advice, kind of echoes back to what my biggest setback was. My advice to whomever that's interested in pursuing a career in science in general, I would say talk to people. Don't be afraid of asking for ask questions and asking for help. And most scientists that I know are pretty nice, and they're usually willing to answer your questions or help out if they could. And by asking questions, it also helps you understand what you don't know yet. And that would be my advice to the next generation.
Great. Was there anything else you'd like to add or say for our viewers?
I just want to say that here at Marshall, particularly in the X-ray group, we're still doing pretty cool and interesting stuff with Chandra, the great X-ray observatory. And also there are other interesting things as well, like XP. I think I saw on the schedule someone else in our group might be talking about that. And also there's the ART-XC telescope. So stay tuned. I am confident that there will be interesting science coming out of it about black holes.
Great. Well, thank you, Dr. Chen, for joining us today. And remember, viewers, science never stops.